Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. We are from Group 3 want to present Lab 5 Entropy Generation in Mixing Chamber.
Procedure. Firstly, open the water supply line to equipment. Second, set the cooling water tank and mixing water tank flow rate to 2 rpm respectively. Third, make sure the water level in mixing chamber indicator not exceed the blue arrow mark. On power switch, set the chiller tank water temperature controller to 15 degree. Set the boiler tank control temperature set point to 150 degree. The heater would turn on to heat up the boiler until the steam generation reach 150 degree. Make sure the steam flow control valve is closed. Wait until the chiller tank temperature reach 15 degree and boiler tank temperature reach 150 degree only for start experiment. Set the steam flow approximately 97% opening. By adjusting the steam flow control valve, check the actual valve opening percentage at steam valve open percentage meter. Record steam flow rate in kg per minute and add this value into the mixing water tank flow rate initial value. Wait until the steam flow, steam pressure, cooling water flow and mixing water flow rate are under steady state. Record the process reading as per state in the table 1 below.
Work process. For this laboratory, first of all, we must understand the theory of anatomical equilibrium and identify the equipment and apparatus used in the laboratory setting. Next, we follow the procedure in the laboratory sheet. We open the water supply channel to the equipment and set the cooling water tank and the mixing water tank flow rate to 2 lpm. We make sure the water level in the mixer chamber indicator did not exceed the blue arrow mark, and then the power switch was turned on. We set the water temperature controller of the cooling tank to 50 degrees Celsius. Then we make sure the steam flow control valve is closed and wait until the cooling tank water temperature reaches 50 degrees Celsius and the boiler tank temperature 150 degrees Celsius. We are just starting an experiment. We set the steam flow to about 67% opening by adjusting the steam flow control valve. Then we take the steam flow rate data in kilogram per minute and add this value into the flow rate of the initial mixed water tank value and wait until the steam flow, vapor pressure, cooling water flow rate and mixture water flow rates in steady state. Then we record the process reading data as shown in table 1 below. Discipline safety regulation during lab. Students must read and understand the laboratory rules and safety regulation thoroughly at the beginning of the experiment. Students need to wear safety equipment such as safety goggles during the experiment. Work area must be clean. It's the user's responsibility to maintain a clean and safe working environment for everyone. Before leaving the laboratory, switch off all the electrical and electronic equipment. Remove plates from the socket unless otherwise instructed. Report all accident and damage to the technician in charge of the departmental safety representative.
Table 1 mixing process test result. Okay, for the state 1, for the cooling water flow rate is 2 lpm. For the cooling water temperature is 22 degrees Celsius. And for the state 2, steam flow rate is 4.95 kg per hour and steam temperature is 145 degrees Celsius. And for the state 3, the mixing tank pressure or pressure mixing tank is 106 kilopascal, and the temperature for mixing tank outlet is 32 degrees Celsius.
Okay, now we come to the outcome for value of enthalpy and value for entropy. So by given the three state, the first state given the temperature is 22 degrees Celsius and we have it in phase saturated water. So by referring to the property tables, the value of temperature, which is 22 degrees Celsius, is in between from 20 degree and 25 degrees Celsius. So in these circumstances, we have to use the interpolation method. So we get the value for enthalpy, which is 92.281, and the value for entropy is 0.3248. For the second state, we have the temperature given, which is 145 degrees Celsius. So the phase is in saturated water, and also the same method, we refer to the property tables. We have the enthalpy value, which is 2739.8, and the entropy value, which is 6.8827. For the last state, we have given the temperature, which is 32 degrees Celsius, and plus pressure, which is 106 kilopascal. So by given the condition of pressure, we have to refer the property tables, so which is in saturated water and pressure table. So given the 106 kilopascal as its pressure, so we have to use the interpolation method to get the enthalpy and entropy. So the enthalpy is 2253.4 and the value for entropy is 6.0204. So the next one is to calculate the heat loss and entropy generation. So to determine the heat loss at air surrounding for 27 degrees Celsius, we use the formula given, which is Q equals to M1H1 plus N2H2 minus in bracket M1 plus N2 times H3. So by include all the given information, we get the value for the heat loss, which is 4,281.03 kilojoules per minute. Next one is to calculate the entropy generation. We have given the formula, which is M3 times S3 minus in bracket M1 times S1 plus N2 times S2 plus Q out over 303 Kelvin. So the value that we get from this calculation is 25.4489 kilojoule per minute times Kelvin.
Assalamualaikum warahmatullahi wabarakatuh. Today, I'm going to present about this question. Based on this experiment, we are able to find all finding data related to mixing process test. From our finding, we are able to determine the phase involved in state 1, which is saturated water phase, where the cooling water flow rate is 2 lpm, while temperature is 22 degrees Celsius. For the second state, which is in hot tank, the temperature is 145 degrees Celsius and the steam flow rate is 4.95 kg per hour, which is in saturated water phase. Last but not least, for the third state indicate that it is in the saturated water phase. The temperature in the mixing tank is 32 degrees Celsius and given the pressure is 106 kPa. Next, we can use the property table to determine the value of enthalpy and entropy based on the temperature in those three states, as well as the pressure in state 3, which is 106 kPa. Then, using the formula given, we were able to calculate the figure for heat loss in the surrounding area, which came to 404,281.03 kilojoule per minute. Finally, we calculate the rate of entropy generation, SGen, which is equal to 25.4489 kilojoule per minute with using the heat loss value. Thank you.
At the end of this entropy generation in mixing chamber experiment, should be able to determine the mass and energy balance for steady state flow system. The entropy change of a system during process is equal to the net entropy transfer through the system boundary and the entropy generated within the system. Besides that, also be able to determine entropy generation in the system. The property entropy is a measure of molecular disorder or randomness of a system. And the second law of thermodynamics states that entropy can be created but it cannot be destroyed. Other than that, can describe the relationship between the pressure and temperature of fluid vaporization, or the three state has different pressure and temperature based on the fluid type. Furthermore, can use property table and draw property diagram of pure substance to define the state of the system. Lastly, record the data taken from the experiment by following the question given.